So today we're going to talk about system of inequalities. We already saw what's an inequality. It's when we have smaller than, greater than, smaller or equal to, greater or equal to. We also saw system of equations. When we had system of equation, we had a line and we had another line and we had to find where they meet. That was a system of equation. Now, a system of inequalities, it's composed of at least two inequalities, at least, that are derived from the same situation, composed of the same variables. Usually, you're going to see we're going to use x and y, but it could be any variables. When they're going to ask for the solution of a system, before, when they were asking for, that's a system of equations, when we had a system of equations, the solution was the point, right? Now, when we have inequalities, we're going to have, let's say that's one inequality, and then the second inequality. So we're going to have more than one point that's going to work to find the solution. So it's going to contain all the pairs that simultaneously satisfy all the system's inequalities. So let's do an example together to see how it's going to work. So first, you have to graph. I'm asking you to graph the inequalities here, and we're going to be able to see where is the solution on the graph. So if you want to graph y is smaller or equal to negative 3 over 2x plus 3, there are different ways that you can graph it. The easiest way, you start with the initial value. You see the initial value here. Initial value is 3. So you can go on your graph, 1, 2, 3. You can graph your initial value. Then you know your rate of change. So number 2, the rate of change. In this situation, it's minus 3 over 2. That means the variation of the y over the variation of the x is minus 3 over 2. That means we have to go down 3 and right 2. So I'm going to start from my initial value and then go down 3, 1, 2, 3, and then forward 2, 1, 2. That's going to give me another point. I do it again, 1, 2, 3, 1, 2. I'm showing the dots in the middle, but really you should erase it because we don't want to see the point in the middle. I'm just showing you so you see how I'm getting there. And then you take your ruler and you're able to graph your line. Okay, that's when y is equal to minus 3x over 2 plus 3. Now what we have to graph is when y is smaller. So we don't want equal here. Okay, we want when it's y is smaller than. So when is y smaller than? It's going to, if you're not sure, you can use the point 0, 0 to check if I'm using the point 0, 0 and plug it here. Then I'm going to get 0 is smaller than 3. Is it true? Yes, so that means 0, 0 has to be in my region. Now, the only problem I see is that my sign here, it's smaller than, it's not equal to. So I made a mistake earlier when I graphed my line because it cannot be a full line. 1, 2, 3. 3, 1, 2. Okay, this is my line. It has to be a dotted line because it's not equal to. Okay, so you're good with this. This is my first inequality. I'm going to use a different color for the other one. My other one is y2 is smaller or equal to 1/2 x minus 1. You can use the same strategy, so go with the initial value and then with the rate of change. If you find it too complicated, you can just use a table of value with 3 points. Why do we use 3 points? Because if you only use 2 and you make a mistake, you won't know. So for example, if x is 0, well, 1 over 2 times 0, I'm going to come and plug my x value here. So 1 half times 0 is 0, minus 1 is minus 1. If I put 1 for my x, it's going to give me 1 half. It's not really nice. I'm going to put 2 for my x. So 1 half times 2, that's 1, minus 1, 0. And if I put 4, 1 half times 4 is 2, minus 1 is 1. And then I can just come on my graph and graph. So 0, negative 1, I have a point here. 2, 0. And 4, 1. And if I use your ruler, please. Oh, is it a full line or dotted line? It's smaller than or equal to. So yes, it's going to be a straight line. Sorry about my line not being on the right. Something like that. And my y is smaller. So smaller is going to be this. So if I'm asking you for the solution, you can take your highlighter and highlight the solution. It would be this line here, going to this point. Is it going to be a full dot or empty dot? Well, because the blue line is dotted line, so it has to be empty, and then dotted over here. And all of this would be my solution set. Okay. And then if they're asking you to give them some points, so for example, if I'm asking you minus 2, 1, is it part of the solution set? Is it included in the solution set? Well, go check. Minus 2, 1. Minus 2, 1, it's over here. Is it part of the solution set? No. So I'm going to write it. It means doesn't belong to the solution set. 6, negative 1. If you go check. 1, 2, 3, 4, 5, 6. Negative 1 is here. Is it part of the solution set? Does it belong? No. If I ask you to check 1, negative 5. Go check 1, negative 5. 2, 3, 4, 5. It's down here. Yes, that one belongs to the solution set. If you're not sure, you can always plug it in, your two equations. 2, 0. Does it belong to the solution set? Here, does it belong? 2, 0. Well, if you want, we can look at the first one. I'm looking, my first inequality is this. Minus 3 over 2x plus 3. Let's plug it in to check. This is my x, this is my y. So 0, is it smaller than minus 3 over 2 times 2 plus 3? Minus 3 over 2 times 2, this is 2 over 1. Multiply, or we can simplify the 2. So that's 0 smaller than 2. Is it true that 0 is smaller than 0? No. So that means our point 2, 0 does not belong to the solution set. So that's the general idea when you have system of inequalities. Now let's look at some special set, because it's not always going to be like this. Okay, if you look at this set that has no solution, what does it mean? If you look at your two inequalities, they have the same slope. If you remember from sec 4, they have the same slope. What does it mean? It means that they are parallel. Parallel. Okay. So what it's going to look like, if you look at the first one, y1, I'm going to start at my initial value 1. Then my rate of change is minus 1 over 2. That's the variation of my y over the variation of the x. So that means that you have to go down 1, forward 2. So starting from there, down 1, forward 2. Here, down 1, forward 2. And so on. And it's smaller or equal to So it's going to give me a line. And my y is smaller than that. So smaller means I'm going to come here. If I want to make sure, I can check the point 0, 0, plug it in. So it's going to give me 0 smaller than minus 1/2 times 0 plus 1. So 0, is it smaller than 1? Yes. So that means my point 0, 0 is in the region that I want to shape. I'm going to use another color. I'm going to use the blue to do this one. So you start with your initial value, that's 3, 1, 2, 3. And then your slope is the same. So minus 1, forward 2, minus 1, forward 2. And by the way, when you have minus 1/2, it's the same as 1 over negative 2. So you can also do up 1, left 2. So up 1, left 2, up 1, left 2. It's going to give you the same. And it's only greater than, so it's going to be a shade dotted line. And it's greater than, so it's going to be that way. So when is it that the blue region and the green region meet? So you see there's no, that's why we say there's no solution. You can also write it like this, which means that there's no place where they're going to meet. You can imagine that it can also be different. If we look at the second example, where all the order pair are on the boundary line. So they would be if the two lines are at the same place. So what does it look like? So I'm going to keep using the green for the first one. If I'm graphing this, starting at 2, so my initial value is 2. So I'm going to go on my graph, initial value is 2. And my slope is equal to 1. 1, you can write 1 over 1 if you want, and that's the variation of your y over the variation of the x. That means up 1, forward 1. So from here, up 1, forward 1, up 1, forward 1. And you can go backward if you want. That's the same as minus 1 over minus 1. So that means down 1, left 1, same thing. And is it greater or equal to? Yes, so that means going to give us a straight line, and it's greater than, so that means greater than this way. Try to graph the blue one. You can always pause the video when you're watching, so try to pause the video, graph the blue one, and you can check after. So the next one also starts at 2, also have the same slope here. So that means it's going to be the same line, but the blue one is going to be smaller than. So where is it that they're both meeting? If you want, you can take your highlighter. It's going to be just on the line. So what would be the equation? It's all the order pair that satisfy the equation of the boundary line. In this case, it would be y is equal to x plus 2. Okay, so it would be x and y that belongs to this. What about if your lines are also parallel, but they're not going on opposite direction? So let's look at this one. So to graph, I'm going to start with my initial value at negative 1, and my 1/4, step 2. This is my variation of the y over variation of the x, means 1 up, forward 4, so 1 up, forward 4. Something like this. And it's greater or equal, so it's going to be a full line, and it's greater than. So this is going to be my region. In blue, I'm going to start again with my initial value at 2. 1, 2. my slope is the same. So if my slope is the same, my lines are going to be parallel. And it's also greater than. So I'm going to go on the top. So what is the region that they're both there? You can take your highlighter. It's going to start on that line. And it's going to be shading up. So your points that belongs to. Now just be careful. Is it the blue line or the blue inequality or the green inequality? Blue inequality. So that's all the points that are solutions. And last one. That's if you have two parallel lines. So I'm going to start again with the green one. Starting at -1. Starting with my initial value. And my slope is -2. I can put it over 1. So variation of the y over variation of the x means I'm going down 2, forward 1. So I'm going down 2, forward 1, down 2, forward 1. And I can go the other way around. Like I said, you can use 2 over -1, and that's the same thing. So that means up 2, left 1. Up 2, left 1. Up 2, left 1. Is it a straight line or a dotted line? Be careful here. We need to check. It's only greater than. So it has to be a dotted line. So dotted line here. And it's greater than. So I'm going to go that way. If you're not sure, say you're not sure this one, you can use the point 0, 0 to check. Okay, so if I take the point 0, 0 is going to be 0 greater than -2 times 0 minus 1. So is 0 greater than -1? Yes, so that means my point 0, 0 belongs to my region. And then I'm doing in blue, I'm going to grab the other one. So first you start at 3. 1, 2, 3. And then you're doing the same slope, so it's going to be parallel. And again, be careful, it's going to be dotted line. Parallel to this. And, well, yeah, sorry, it's not really nice. Make sure you're going, wait, 1, 2, 1. Okay, it should be more like this. Parallel. Like this. And it's smaller than. So I'm going to come this way. So where is it that they're both working? What's the region that's including both? It's between this and this. And it's all in the middle here. So that would be my solution set. This one is really hard to write in Word. So we really have to look at the picture. So now what's next? You can work on activity 1 on page 104. If it's not done, make sure you correct it before you move on to the next one. Try the Technomat, page 106, then also correct it before you move in to the textbook practice, page 109, number 1, 2, and 4. And you can work on activity 2 after, page 105, then correct it. You can start reading page 108. That's what we're going to do next class. Have fun.